All right, welcome to The Explainer. Today we're going to tackle something that, yeah, it can look a little scary at first, but I promise you it's one of the most logical and kind of satisfying parts of algebra. We're talking about algebraic fractions. So let's just dive right in. Okay, so you know regular fractions, right? The ones we've all known for years. But what if I told you they have a secret identity? That they like to wear these really elaborate disguises? Like, what if the number 1/2 didn't always look like 1/2? And believe it or not, what you're looking at here, they're the exact same thing. I mean, on the left, 3/6, that's a no-brainer, right? It's 1/2. But that thing on the right, with all the x squareds and variables flying around, yep, that is also just 1/2, hiding in a clever costume. And that's really the big secret here. Algebraic fractions, they play by the exact same rules as the simple fractions you already mastered ages ago. So, to pull back that curtain and see what's really going on, here's our game plan. We're going to start with what these things even are, then get into simplifying, which is super important. After that, we'll hit multiplying and dividing, tackle the whole common denominator quest, and then wrap it all up in your very own algebraic toolkit. Okay, section 1, algebra's version of fractions. The key thing to remember is that the rules are the same, we just have different players on the field. So let's get one thing straight, right from the get-go. We are not learning some brand new complicated math today. Nope. We're just taking the rules you already know and applying them to, well, to new players. Instead of just numbers, we've got variables and expressions. Seriously, if you can handle 3/6, you've already got the foundation for all of this. All right, on to section 2, simplifying. This is the first and honestly most important step, finding and canceling common factors. I cannot stress this enough. The single most important skill you will learn for this stuff is simplifying. It is the golden rule. Before you do anything else, multiply, divide, whatever, you have to stop and ask yourself, can I make this thing simpler? And simplification sounds all formal, but really it's just a fancy word for cleaning up the fraction. You're just tidying it up. It's all about breaking down the top part and the bottom part into their basic building blocks, that's called factorizing, and then just crossing out anything that's the same on both sides. That's it. Okay, let's see this in action with an example. We've got h squared minus 1 on top and h squared minus h on the bottom. So step 1, we got to spot the patterns and factor everything. The top, h squared minus 1, that's a classic pattern called difference of two squares. It breaks down really nicely into h minus 1 times h plus 1. Easy enough. Now the bottom, h squared minus h. They both have an h in them, so we can just pull that out. That gives us h times h minus 1. Okay, now comes the fun part. Do you see it? We have an h minus 1 on the top times and on the bottom. So we can just cancel them out. And what are we left with? Just h plus 1 over h. Boom. Simplified. Section 3, multiplying and dividing. The action steps. Seriously, once you've got that simplifying skill down, this next part is going to feel like a total breeze. I know it looks messy, but the process is super straightforward. When it comes to multiplication, the rule could not be simpler. You just combine everything. Multiply the top parts together, multiply the bottom parts together, and then, you guessed it, simplify what you've got. So let's run through one real quick. We've got 3a over b squared times b cubed over a squared. So, step 1, multiply the numerators. That's 3a times b cubed, which gives us 3ab cubed. Step 2, multiply the denominators. B squared times a squared, that's a squared b squared. Now we just clean it up. We have 1a on top and 2 on the bottom, so one of them cancels out. We have 3 b's on top and 2 on the bottom, so 2 of them cancel out. And what's left standing? A nice clean 3b over a. Done. Okay, so that's multiplication, but what about division? Now this is where I see people get tripped up sometimes, but honestly, it all comes down to knowing one simple, powerful trick. It's a little secret move that turns a scary division problem into an easy multiplication problem we already know how to solve. You ready for it? The big secret is invert and multiply. That's it. That's a whole trick. You see, you never actually divide fractions. Ever. What you do is you take the second fraction, you flip it completely upside down, that's the invert part, and then you just multiply. It's that simple. Check it out. Here's the trick in action. On the left, you see the original division problem. To solve it, all we do is take that second fraction and we flip it. So it becomes 2k squared over 3h to the 5th. And just like that, poof, it's a multiplication problem. And we already know exactly what to do with that. Section 4, the common denominator quest. Okay, here we go. It's time for the final challenge, the boss level of algebraic fractions, adding and subtracting. This is where everything we've learned so far, factoring, simplifying, all of it, has to come together. So here's the absolute #1 rule you have to remember. You cannot, I repeat, cannot add or subtract fractions unless their denominators are the same. Period. It's like they're speaking two totally different languages. Trying to add 1/4 and 1/3 just doesn't work. And it's the same exact problem with the algebraic ones here. They just can't be combined yet. They need to find some common ground first. And that common ground has a name. It's called the least common denominator, or the LCD. Think of it as the shared language that our fractions need so they can finally talk to each other. Finding that LCD, that's the key that unlocks the entire problem. So let's break this down with our example. We have two different denominators, m plus 1 and just m. To find our shared language, our LCD, the easiest way is just to multiply them together. So our common denominator is going to be m times m plus 1. So what does the first fraction need? It's got the m plus 1, but it's missing the m. So we multiply the top and bottom by m. And the second fraction, it's got the m, but it's missing the m plus 1. So we multiply its top and bottom by m plus 1. And look at that! Suddenly they both have the exact same denominator. Now we can combine them. Okay, we've got our common denominator, so let's just put the numerators together over it. We have m minus 4 times the quantity m plus 1. Now, be careful here. We have to distribute that -4. So that becomes m minus 4m minus 4. We combine the m's, and what do we get? Our final, beautiful answer, -3m minus 4, all over m times m plus 1. All right, Section 5, your algebraic toolkit. We did it! We made it through the 4 core strategies for success. So let's do a quick recap and pack all of this into a handy toolkit that you can use anytime. Here it is, your 4 core strategies. Number 1, and say it with me, simplify first, always. Number 2, for multiplication, just go straight across. Top times top, bottom times bottom. Number 3, for division, remember the trick. You just flip the second one and multiply. And finally, number 4, if you're adding or subtracting, your main quest is to find that LCD. That's it. That's the whole playbook right there. But, why does any of this actually matter? Is it just for a test? No way. This isn't just some abstract math puzzle. The ability to handle these complex expressions, to simplify them down to their core, that is fundamental logic. It's the kind of thinking that goes into engineering massive bridges, writing the code that runs your phone, and making huge breakthroughs in scientific research. So, there you have it. You've basically learned the secret language of algebraic fractions. You know how to command them, simplify them, transform them. So the real question I want to leave you with is this. Now that you have these powerful tools in your toolkit, what kind of complex problems out there in the world do you think they could help us solve? Thanks for joining me on this explainer.